Okay, class, picking up where we left off at. This was an additional 2 pages that I did not know was in the course pack. So we have to pick up where we left off on the last video. And this is page 186 in your course pack. So we know that 2 to the third power is actually 2 times 2 times 2, which is 8. 2 to the second is 2 times 2, which is 4. And 2 to the first is just 2. This suggests that 2 to the 0 is 1. So if you notice here, as we go down by one exponent, you keep dividing it by 2. Does everyone follow that? So if we so x to the 0, we know is 1. So we now have the 0 exponent property. 7 to the 0 is 1. Now, since this whole parenthesis is taken to the 0 power, it's 1. Does everyone follow that? Now here, this whole parenthesis is taken to the 0 power. So this would be 2 times 1, which is just 2. Now it says continue the previous pattern. We know that this is 4, 2, and 1. This suggests that 2 to the negative 1. Now listen, every time we went down an exponent, we divided by 2. So we have 4 divided by 2 gave us 2, 2 divided by 2 gave us 1. So 1 divided by 2 will give us 1/2 because we still went down by an exponent. So we kept subtracting 1, and that means we divide by 2. So now the negative exponent property for non-zero x to the negative 1 will be 1 over x. Now, if you notice here with this 2 to the negative 1 became 1 over 2 to the first, which was 1/2. And this is 1 over x to the first, which is 1 over x. Because listen, whenever you deal with a negative exponent, you take the reciprocal of the base, and the exponent still will stay with the base, but the exponent will become positive. Does everyone follow that? Okay, so now, go down here. We have 7 to the negative 1. We know the reciprocal of 7 will be 1/7, right? And then this negative 1 will become positive 1. So it'll end up being just 1/7. Now we look here at B. We have in parentheses 3xy squared all to the negative 1. We could just take the reciprocal of what's in parentheses. So this would be 1 over the parenthesis 3xy squared to the positive 1 power, which would just be 1 over 3xy squared. Okay, now we come here to C. Now with C, if you notice, we have a negative exponent in the numerator and a negative exponent in the denominator. Whenever you're dealing with a fraction, all you have to do to satisfy this is switch the locations of these values that's taken to the negative exponent and make it positive. So 7 will still remain 7. But the y to the negative 1 will come up to the numerator and become y to the first. X to the negative 1 will go to the denominator and become x to the first. So your final answer will be 7y over x. Now, if you notice, they switch locations, right? Does everyone follow that? Okay, now, you scroll to the next page. It says more negative exponent properties. X to the negative n, we know that this would be 1 over x to the positive n, just like I told you all. Okay, now, 1 over x to the negative n. Now listen. I already told you all that it'll switch places, right? So that would mean that this will become 1 times x to the n. And since this will come up to the numerator, this will be 1. So this will just be x to the n over 1, which is x to the n. Does everyone follow that? Because remember, you still need a denominator. It does not just disappear. When that moved up to the numerator, that became positive 1. Does everyone follow that? Okay, now, one thing I want to show you as well. I showed you the practical way of doing this, but I need to show you the mathematical application of this as to why 1 over x to the negative n becomes x to the n. Now going off to the side, remember how I told you all when you have a negative exponent, you would take the reciprocal of the base and the exponent will become positive, right? So this really becomes 1 over x to the n, because the reciprocal of x is 1 over x, right? And this exponent will become positive. So it'll be 1 divided by 1 over x to the n. So we know this will become 1 times, we'll take the reciprocal, which would be x to the n, and our final answer will be x to the n. Now this is the mathematical reasoning behind it. But if you just remember this rule, you don't have to do all of this. Does everyone follow that? Okay, now, we have 8 to the negative 2. So we know it'll be 1 over 8, and then 2 will become positive. So it'll be 1 over 64. Now we look here at b. Now both of these are taken to a negative exponent, so we know we switch their locations. So this will become 4 squared in your numerator, and this will become 3 to the third power in your denominator, which will give us 16 over 27. Are there any questions? Okay, now we go here to C. We have 2x to the negative 5, y to the third. Now we know this x to the negative 5 will go to our denominator. So it'll be 2y cubed all over x to the fifth. Does everyone follow that? Yes. Okay, the 2 is not taken to a negative exponent, right? The only thing that's affected is this x to the negative 5. So let me just show you this mathematically as well. This really would become 2 times 1 over x to the fifth times y to the third. And you know you can put all these over 1. 2 times 1 is 2 times y to the third to give us 2y to the third. 1 times x to the fifth is x to the fifth times 1 is x to the fifth. So this is the same exact thing. Now we come here to D. 8 will be in our numerator. X to the 13th will be in our denominator. Now we come here to example 3. Example 3. First we look here at these numbers. 21 and 7. What's 21 divided by 7? 3. Now we don't know if we're going to need a denominator yet. So let's go with the rest of the problem here. So now we have m to the third, m to the negative 5. Isn't 3 bigger than negative 5? So that means that our answer is going to be in our numerator. So this, we could go off to the side. This would be m to the third minus a negative 5. What's 3 minus a negative 5? Is 8, because this becomes 3 plus 5. So this would be m to the 8th. So it'll be 3m to the 8th. Now we look here at our ends. Now if you notice here we have negative 2 and 3. Isn't 3 bigger than negative 2? So that means everything will go in the denominator. And this is what will happen. N to the negative 2 minus 3 will give us n to the negative 5. N to the negative 5 going into the denominator will become n to the positive 5. Does everyone follow that? So this is our final answer. 3m to the 8th over n to the 5th. Now we go here to B. Now if you notice, everything in this parenthesis is taken to the negative 2 power. Now, we know what that would mean here. This would end up being 6 to the negative 2, x to the positive 6, because a power to a power we multiply, right? So now, that 6 to the negative 2, we know that this will go in the denominator, but the exponent will be positive. So it'll give us x to the 6th over 36. Okay, now we go to C. Now if you notice here with C, before we move anything, I would just like to take everything in these parentheses to these negative exponents. So we know this would be 2 to the negative 3, x to the 12, and y to the negative 3. All over. This would be 4 squared, x to the 4th, and y to the negative 10. Now, because this is 2 to the negative 3, we know this would go down in our denominator, right? So, 2 to the negative 3 in our denominator, we know that would be 2 to the 3rd power. And we know 4 squared would stay in our denominator too. X to the 12 will remain in our numerator. So we have x to the 4th, and then y to the negative 3 over y to the negative 10. Now, let's watch what happens here. In our denominator, 2 to the 3rd is 8 times 4 squared is 16. Now we could take our calculator and take 8 times 16. That would give us 128. So our denominator here would be 128. Now, as far as this number is concerned, now we go to the x's. X to the 12th divided by x to the 4th, we know will leave us x to the 8th. Because 12 minus 4 will leave us 8, and that will remain in the numerator. Now we look here, negative 3 and negative 10. Isn't negative 3 larger than negative 10? Yeah, so that means that our final answer is going to be in the numerator. Now, if you want to look at this off to the side, it would be y to the negative 3 minus a negative 10. So that would be y to the negative 3 plus 10, which would be y to the 7th. So your numerator would be will have y to the 7th in it. So this is your final answer. X to the 8th, y to the 7th over 128. Are there any questions on this problem?
Wouldn't negative 3 be bigger than negative 10?
Yes, that's why I said the numerator is larger than the denominator. So that's why your final answer with these y's will be in your numerator.
I thought you said negative 10.
No, okay, I don't think I did, but the video would tell which one of us said what. So I could have said it, but it's on video, so you got me if I did. Okay, so now we got D here. Now if you notice, there's no outside exponent. So first we can multiply across. 16 times 25 is 400. A to the negative 2 times a to the 4 will give us a squared. And b times b to the negative 5th will give us b to the negative 4th. Because we know that b is really taken to the first power. 15 times 8 will give us 120. A to the 5th times a to the negative 7 is a to the negative 2. B to the negative 1 times b to the negative 2 will be b to the negative 3. Because remember, when we add the same base, we add the exponents. Now, if we look here, 400 and 120. Now, we know both of them has 10 in common, but actually both of them has 40 in common. Let's try 40 for both of them. So this would give us 10 for the numerator, 3 for the denominator if we divide both of these by 40. Now, a squared divided by a to the negative 2. We know we can go off to the side. It would be a to the 2 minus a negative 2, which would be a to the 4th. So that will give us a to the 4th. Now, b to the negative 4 over b to the negative 3, we can go off to the side. B to the negative 4 minus a negative 3, which would give us b to the negative 1. Because it would be negative 4 plus 3, which would be b to the negative 1, which means that goes in the denominator, so the exponent would be positive. So this right here is our final answer, and we are done. Now, one other thing I want to say before this video ends. With your final answer, you could never have a negative exponent. Remember, you could not have a negative exponent for your final answer. So now the video is done.